So solving logarithm equations. Remember, logarithms and exponentials are inverses of each other. So as you're solving the logarithm equations, you're going to keep in mind your exponential properties. So let's start with one that looks like this. We have log of 3x plus 1 equals 5. Okay, so again, the inverse of this is an exponential equation. So which exponential equation is it? All right, luckily for us, we see this is a common log. So it has a base of 10. All right, so what we're going to do is we're going to start that inversion process. If you take the inverse of this side, it just cancels out the log. Remember, it's like doing the square of a square root. It just cancels each other out and you're left with what's left inside. So if we were to actually raise this, do 10 to all this power, it's basically just going to cancel out and you're going to be left with 3x plus 1 on this side. But if we did 10 to this power here, okay, we have to do it to the other side as well. So we're going to take that and do 10 to the 5th power. Okay, so basically all we've done here is we did the inverse process here. So the inverse of the logarithm, remember, is to do 10 as your base and raise this to a power, okay? And what you do to one side, you do to the other. So if we raise this, said 10 to this power, we got to do 10 to this power over here too, okay? So that was a lot. That was kind of a mouthful, and I don't know if it came out real clear, but basically you cancel out the log over here, and you make 10 your base and make whatever values on the right hand side as your exponent. Alright, so now we've got that set up. What you have to do now is find 10 to the 5th power. And 10 to the 5th power, of course, is a 1 with 5 zeros. Okay, 100,000. So now we just solve the equation like you would any other equation. Subtract 1 from both sides. 3x equals 99999, and then we divide by 3, and you're left with x equals 33,333. Now, of course, how do we check? You substitute this back in. So you can use your calculator and take this 33,333, substitute it in for the x up here in your original equation, and see if it works out to give you 5, which it should, okay? So let's look at another one. Let's say we have log of 7 minus 2x equals -1, okay? So again, find the inverse. So it cancels out the log over here. And since this is a base 10, we're going to create an exponent on the right-hand side with a base of 10. So I have 7 minus 2x on the left, and I have 10 to the -1 power on the right. Now you need to remember your negative exponents. Negative exponents mean that you are going to take this and move it across your fraction line. So if you have 10 to the -1 power, that really equals 1 over 10. And since in this case it may be easier to work with decimals, we're going to convert that to a decimal, which is 0.10. Okay, 1/10, 0.1, or 0.10. All right, so I'm going to rewrite it. Now, again, solve this like you would any other equation. So we're going to subtract 7 from both sides, and that should leave me with, what, a -6.9? Hopefully I did my math correctly there. Then I'm going to divide by -2, and x is going to give me 3.45. Okay, and again, how do you check it? Take that 3.45, substitute it back into your original equation for x. So you type into your calculator the log of 7 minus 2 times 3.45 and see if you get something close to -1. Hopefully you do. All right, so another one. Let's say you have Oh, this is a good one. Okay, so let's do 2 log of x plus 1 equals 5. Okay, so this one's a little bit different. We have that 2 in front of the log. What we need to do is think about our logarithm properties. Remember, if you have a 2 out front, that means at one time it was an exponent. So we're going to convert it back to that exponent form. So I'm going to have the log of x plus 1 to the second power equals 5. Okay, and then we take the inverse, so it gets rid of my log over here. I have x plus 1 squared equals 10 to the 5th power. Okay, so we know that 10 to the 5th power is going to give me 100,000. Okay. Now, again, we solve this equation like we would any other. The biggest thing that I wanted to point out with this one is what happens when you have a number in front of your log. Okay, so now that we do this, most of you are probably sitting there thinking, oh, I need to write this out and do my FOIL and expand it and da-da-da-da-da. And that's good that you're thinking that, but that's not actually what we're going to do this time. Let's keep life simple. Okay, so what we're going to actually do is the opposite of squaring something is to take the square root. So that's what we're going to do first. Okay, we're going to take the square root of both sides. And what that does over here is it cancels out, because anytime you do the square root of something squared, it simply cancels and you're left with whatever the base is. So we have x plus 1 equals the square root of 100,000. So let's throw that into our calculator. Clear that. So second square root, 100,000. Make sure I have 5 zeros. And I get 316.2. Okay, and now I subtract 1. X equals 315.2. Again, if you want to check it, plug that 315.2 back in for x and see if you don't get 5.